Okay, so let's continue where we let off yesterday. We had just done these couple of questions in Module 4, Lesson 2 about Ty's math class and who got A's, and Ty's art class who got perfect scores. 12% of the 25 students in the class got perfect scores, and we figured out that 12% of 25 was 3. And something I want you to notice is that in this question, we were trying to figure out what 20% of 30 was. And we did like this fancy algebra stuff that I like to do. But really, if you just remember that of means to multiply, and you know that, okay, I'm just trying to find 20% of 30, it just means 20% times 30 or 0.2 times 30. And you didn't have to write this x equals stuff. Like, you could have just literally grabbed your calculator, done 0.2 times 30, and been done with it. Same thing here. If you know you're trying to find 12% of 25, that just means 12% times 25. Grab your calculator, do 0.12 times 25, and be done with it. You don't necessarily need to do it like this algebraic way that I'm always going to show you how to do, just because it's my preferred method. But after a while, you'll just get used to, oh, if I'm trying to find the part in the question, let me just multiply percent times whole. And then as we get on to different types of questions, when we have the whole and the part and we want to find the percent, oh, I'm just going to divide these two numbers. And then when you're given the part and the percent, which we'll get to those types of questions later, we haven't seen one yet, but after a while you'll just know, oh, I just need to divide these two things, right? And you'll know the exact operation to do depending on the pieces you're given. I'm always going to do it algebraically just because I prefer it that way, but you know, if you've memorized the step to solve them, then after a while you don't have to do all this kind of like algebraic work that I'm choosing to do. All right, so moving on to the next question in the book, it says, in Ty's English class, 70% of the students completed an essay by the due date. There are 30 students in Ty's English class. So how many completed the essay by the due date? So, like, thinking about what I just said about the previous two questions, the crux of this question essentially comes down to, what is 70% of 30? And so we're going to solve this by doing 70% times 30, or 0.7 times 30, I should say. And that's probably going to come out to, I think, 21. But I'm going to go through this whole process of like how I would do it if I were doing it. So I see that they gave me the percent, it's 70%, and they gave me the whole, all the students in the class, which is 30. And then my job is to identify the part, which will be 70% of 30, and I'll mark it as an unknown x for now. And then x is just going to equal 0.7 times 30, because I'm trying to answer the question, what number, so that goes with the variable there, what number is, so that means equals 70%, that's the 0.7, of, that's the multiplication dot, 30. Obviously that's the 30. So each piece of this sentence corresponds to one piece in this algebraic equation that I'm making. And that's a big part of the reason why I like to show students how to do it this algebraic way each time. And so you can grab your calculator and do 0.7 times 30, but I'm pretty sure, you know, 3 times 7 is 21, and the fact that this is 30 will move the decimal point over one spot, and you get x equals 21. So 21 students turned in the essay on time, I think is what this question's about. Turned in the, is it an essay? Yeah, essay on time. All right, let's move on. It says, oh, it's funny here. It says, example 3, an algebraic approach to finding a part given a percent of the whole. Okay, so this one, it's going to be the same thing. It's going to be another one where, you know, it's our job to find the part when they give us the percent in the whole, which is exactly what the last 3 questions have been already. But this is going to teach us how to do it algebraically. But we've already been doing it algebraically, so this shouldn't be any different for us. It says a bag of candy contains 300 pieces, of which 28% are red. How many pieces are red? And the first questions it asks are, which quantity represents the whole? Well, the whole 300 pieces in the bag, right? which of the terms in the percent equation is unknown? Define a letter or variable to represent the unknown quantity. So in this case, the unknown quantity is how many are red, and let's just make, oh, we've been using X. How about we go R this time, just because it's red candies. So we're essentially defining the variable R to be the number of red candies. Okay, so now write an expression using the percent, which was 28%, and the whole, the 300, to represent the number of pieces of red candy. So the expression would just be, we want to do 300 times 28%, which is 0.28. I really hate it when I wind up with a multiplication dot right next to a decimal point, because that just looks weird to me. So I'm going to put the 0.28 in parentheses just to separate those two dots. Remember, parentheses always mean multiplication anyway, so now I don't even really need that dot. I've got redundant notation here. All right, so now write and solve an equation to find the unknown quantity. So that just means take this expression here and write, well, the number of red candies equals 300 times 0.28. I just took my expression and put it in an equation with my variable there. But this equation literally matches up with the word sentence, what number, right, that's represented by R, is 28% of 300. It would have been better if I put the 0.28 in front of the 300, because now things are sort of out of order, but it doesn't really matter. So is, and then 28%, that's here, of, that's the multiplication that's happening right here, and 300, that's right there. Okay, so let's move on. Oh, I think we're supposed to solve it on the other page, huh? Write and solve an equation. Oh, okay, so I guess we got to do 0.28 times 300. So you go and grab your calculator. You're supposed to have one with you, and do 0.28 times 300. I'll wait a second for you to punch it in. All right, so hopefully you already have an answer, but I'm just going to show you how I would do this one without a calculator. I'm thinking these two zeros on the end of 300 are going to push this decimal point 2 spaces back. And then 3 times 28, if I do that in pieces, I've got 3 times 20, which is 60, and 3 times 8, which is 24. You put those together, it's 84. So R equals 84. There are 84 red candies. I hope you're actually like doing the things I ask you to when you watch these videos. If I say, hey, pause this, figure out what this equals before I show you, or, you know, get this answer while I wait a few seconds, you're supposed to be, you know, having your electronic copy of this book open on another window or tab on your computer so you can flip over to it in case it's easier to see. You're supposed to have some sort of scratch paper or something to write on, and some sort of pencil or pen that you're working with, so that you can do these things when I ask you to. And you can do it more often than I ask you to. If you're watching the video and you want to do like every question before I show you the answer, that would be even better. It would take you a long time, but you know, I hope you're not just ignoring me when I ask you to do that, because there's a reason for it. If you attempt a question, then you're, you know, making your brain work its own way through it. And then when you see how I do it, if your answer is the same as mine and the process is essentially the same, then you get confirmation that you understand what's going on and that you can do it. And if you don't get something right, or your process is different than mine, or you get a different answer, then you get confirmation that, hey, I need to practice this a little bit more, or I need to ask Mr. Thomas a question in like the Zoom meetings online. Like that could be something that you could circle or like remember, so that when it's your turn to come to like your class period's day to come to a Zoom meeting, you ask me about it. Because sometimes when you're just watching a video and you're not doing any of the work, you might think in your head that you understand and that you could do it, and your brain will sort of wander off. But then when you actually go to try it, you're like, wait, no, I actually don't understand this. And so you pausing and taking the time to try something before I show it to you is a way to check sort of where you are when it comes to that. So this is a continuation of that question from the previous page. It says, a bag of candy contains 300 pieces, of which 28% are red, which we figured out in the previous question. That was 84. How many pieces are not red? I don't know why I'm saying the word red all weird. Write an equation to represent the number of pieces that are not red, n, and they want us to use n to stand for the number of pieces that are not red. Well, there's a couple different ways you could do this one. You could say, well, n has to equal 300 minus the 84 reds, right? That's probably the easiest way, but that's not my favorite way because it doesn't let me talk about something with percents that I want to talk about. I want to instead talk about the fact that if 28% are red, then what percent are not red? I want you to think about that for a second before I just tell you, okay? If 28% of the candies in the bag are 28%, then what percent of them must not be red? All right, so hopefully you came up with 72%, right? Because 100% makes a whole. And if you take away the 28% that are red, you come up with 72%. And so, yeah, this is probably the easier way to find this answer, but the way that's going to help us learn what we're trying to learn right now would be to think of it as 0.72 times 300, right? 72% of the 300 candies are not red, which is n. And these two things should get you the same answer. So let's see here. 300 minus 84. Let's go ahead and punch it in. Let's be lazy and do it this way. 300 minus 84. So we get 216, right? Well, we better get 216 from this one as well, or else something fishy's going on. So I'm going to leave you to check that one, and I think I'm going to just move on. I'm going to trust that you're doing that. So B says use your equation to find the number of pieces of candy that are not red. Oh, well, we kind of already did that up there. And then C says Jaleel told his math teacher that he could use the answer from example 3 and mental math to find the number of pieces of candy that are not red. Explain what Jaleel meant. I think what he's saying is that he could use this method, right? He's saying, oh, well, I already know 84 are red, so let me just subtract that from the 300 total candies. And a lot of kids could do that, right? 300 minus 84. Oops, I was off the screen. 300 minus 84 in their head. So I would think that's probably the mental math that he's referring to. So we don't necessarily need to write anything there. All right, example 4. It says, Zoe inflated 24 balloons for decorations at the middle school dance. If Zoe inflated 15% of the total number of balloons inflated for the dance, how many balloons are there total? Solve the problem using the percent formula and verify your answer using a visual model. All right, we don't need to do the visual model. We're working with percents here. We don't need to do that. So when they say the percent formula, to be 100% real, do I know exactly what they mean by that? No. But I think they're just referring to the algebra that we've been doing. I think the method that we've been using so far is appropriate. So what I'd like you to do is I'm going to help you identify the pieces in this question, and then I want you to try to answer it from there. So obviously they've given us the percent. It's 15%. And then she inflated 24, and that was only 15% of the total, right? And so if I'm thinking about that trick or that rule from earlier, that the thing that follows the word of, right, after of is the whole, then I think the whole in this case is going to be the total number of balloons, and the 24 that she inflated was only part of that. So part equals 24. The whole in this case is the unknown. And so we'll make that x in this case. So this is the first question we've come across that's like this. And I think it would be interesting for you to try to do it without me showing you first. Don't be discouraged if you mess it up, because I haven't even shown you how to do one of these yet. So take your best shot at it. Do what seems like it makes sense to you. Pause the video, and then I'll show you how to do it in a few seconds after you pause. All right, let's switch colors. We've been using purple for quite a while, this whole lesson. What color have I not used in a while? I haven't used green in a while. I'm going green. So essentially what we're trying to answer here is the question, 24 is 15% of what number? I really like rewriting these complicated word questions about grades or balloons or whatever as just these short sentences that have like the pieces that I know and just is, of, and what. Because I know where there's an is, I'm going to put an equal sign. Where there's an of, I'm going to multiply. And where it says what, I'm going to put a variable. And if I just have those pieces in the right order, then I'll come to an equation that can solve the question for me every time. So this question essentially comes down to the 24 balloons that she blew up is 15% of the total, which is what number? We're trying to figure that out. And now I can just rewrite that as the equation 24 equals 15%, that's 0.15 of, let me use parentheses for multiplication this time just to do it a little different. What number? X. And now to solve this algebraic equation, since I have 0.15 times x, I need to divide both sides by 0.15 to get that x by itself. And so x is going to equal whatever 24 divided by 0.15 is. These are the weirdest out of all the questions, because essentially what it boils down to is when you have the percent and the part, the way you find the whole is this operation here at the end of this equation. It's always whatever the part is divided by the percent, because you're essentially undoing what we've done in every other question. Here we had the whole in the percent and we wanted to find the part, so we multiplied. Oops, I'm off the screen again. In this one we multiplied to find the whole, sorry, to find the part. In this one we multiplied again to find the part. And here again we multiplied in order to find the part. But when we get to this one, now we know the part and we want to find that whole, so now we're dividing. It's just like it's an inverse operation because of an inverse relationship. So 24 divided by, I feel like I didn't hit that. Okay, 0.15. This should be like 120 something, I'm guessing. Oh, a little bit bigger than that. 160. All right. So there were 160 balloons at this dance. There were 160 balloons at the dance. It's okay if you got that one wrong. Like if you multiplied 24 times 0.15 and you got some small number or whatever, it's okay to get things wrong, especially when you're like very first learning them. You know, just now you've seen how to do it and hopefully you'll get it right next time. All right, yeah, this will be the last thing we do in this video. So it says example number 5, finding the percent given a part of the whole and the whole. Okay, so this is the last type of question that we haven't done yet. This one, they're going to give us the part, they're going to give us the whole, and the percent's going to be the unknown. So Haley is making admission tickets to the middle school dance. So far, she has made 112 tickets, and her plan is to make 320. What percent of the admission tickets has Haley produced so far? Okay, so it sounds like the percent is unknown, so we'll call that X. The part, well, that's the 112 that she's made so far. And the whole, that's the 320 that she needs to make. It says solve the problem using the percent formula. I'm just going to assume that they're talking about the algebraic strategy that we're using right now. And then we're not going to worry about verifying using a visual model. So I'm going to rewrite this question as what it really boils down to. 112 is what percent of 320? And now I can make an equation out of that simple statement. It's just 112. Oops. 112 is, that's where I'll put my equal sign, what percent? So I got to use a variable here. And the way I like to do this is I just use a variable to stand for the number that I'm going to get here, but I have to remember that at the end of this, that number I get will be in a decimal or a fraction form, depending on how I decide to answer the question. And since they want the answer to be a percent, I need to convert that to a percent at the end of 320. So times 320. Unconventional, the number is supposed to go in front of the variable, but I'm breaking rules. All right, so to solve this for x, I need to divide both sides by 320, and I get x equals whatever 112 divided by 320 is. 112 divided by 320, it's going to be 0.35. But see, that's not my answer. That says a decimal. I need to write it as a percent. So I convert to 35% equals x. And so it sounds the answer is she has made 35% of the desk is all shaking. The video is getting shaky. Of the tickets so far. So when you're given the part and the whole, and your job is to find the percent, you just wind up doing a division. You wind up doing whatever the part was divided by the whole. And so usually that will come out to a decimal smaller than 1, because in most questions the part is smaller than the whole. But you will come across some questions where the part is actually bigger than the whole, and this number will come out bigger than 1, which just means you have a percent greater than 100%. All right, I think that's good for this video. That's the end of lesson 2. Oh, you know what? I think this might be the formula that they're talking about that they want us to be using. It's just the fact that the part equals the percent times whole, which we saw in the first few questions of this lesson. All right,